Hello, this one we're gonna derive derivative function, okay, applying this formula. And let's get started. Please have your paper pencil with you and so that you can follow me. And if you have a different way to do that, it's all welcome. And I just do my way and feel free to do your own, and then we compare notes. All right, f of x plus h. Okay, that's going to be f of x replaced by x plus h. And we're going to form the quotient. We're going to form the quotient. Right here, the denominator, be careful about the alignment. So numerator, f of x plus h minus f of x equals 2. So obviously we have a complex fraction. If you like to, we can find the common denominator. Common denominator would be root of x plus h multiply, root of x plus h multiply root of x. Okay, you can just keep them separate because oftentimes it's much easier to handle it this way. Okay. Numerator times numerator, denominator times denominator. So denominator times denominator, numerator times numerator, but we need to distribute this piece to each one in the difference. Okay, so we will reduce root of x plus h multiply 1 over root plus 1 over plus 1 over root plus this makes 1. Okay, this makes 1, and 1 can be omitted. 1 over root x and the root x will be reduced. We got to this part, and then what do? We still cannot directly substitute because that's going to produce a zero denominator. We cannot use limit law, and of course, you guessed it, we're going to multiply the conjugate of the numerator. The conjugate of the numerator, of course, is from minus now becomes plus. So we create a new number by, it's 1, right? Anything times 1 stay the same, so equal sign is validated. And we get to the next step. And the numerator times numerator, right? That's going to make a squared minus b squared. Denominator multiply denominator. We need to insert a parentheses here. So this parentheses is absolutely necessary. Next, we got this part equals to x, this part equals to x plus h. But we must put a parentheses around it, or minus x minus h. The next step, we open up the parentheses. I usually like to keep this step, okay, because when I go back to check, this step will give me assurance that I've done it right, okay? So now by this time, we just have negative h on the left on the top, h and h reduced. Now we can do the limit. Take limit as h approaching 0. Okay, so that's going to be the limit. That's going to be the limit of the whole of the reduced part. Direct substitution, everywhere h will be replaced by 0. And we're here, almost. Root x plus 0, that's root x times root x, that's gonna be x, right? Root x squared. Inside here is 2 times root x under -1, under -1. And you can put a 2 in the front, okay? And you're done. But if you like, you can write it as 1/2 x raised to the power of -3/2. Okay? Domain, let's look at the domain, right? So we have function, right? Its domain is x larger than 0. Cannot be 0. Its derivative function equals to either one of these. It's the same domain. It's the same domain. And we're done. We're finished. Thank you for watching.